Good morning, everyone. I am Dr.A.Sethupathy, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering, Coimbatore. Today, we are going to discuss about introduction to motors and actuators, which usually in the IoT systems. So, how to use the motors and actuators by controlling the microcontrollers using Internet of Things. So, motors and actuators are essential components that power a wide range of machines and devices. So they convert electrical energy into mechanical motion, enabling precise control and automation in various applications. So any machine or equipment that is one connected with the actuators. So without actuators, there is no motions. So the motors and the actuators, these are how to connect in the Internet of Things IoT systems used in the industries. So this is the topic we discuss. So microcontroller based motor control. So motors and actuators, these are controlled by the microcontrollers where we are using in the Internet of System applicable in the industries. So how to control the motors? The first one is input signals. So microcontrollers receive input signals from sensors or other control devices to determine the desired motion operations. The next one is motor drivers. So microcontrollers use specialized motor driver circuits to supply the appropriate voltage and current to the motors. Then feedback monitoring. So microcontrollers can monitor motor performance and adjust control signals in real time for precise closed loop controls. So the closed loop control we are used in this system. So if the error occur in that time, the closed loop will be send the signals to the initial stage. So we will rectify the error and process continuously. So pulse width modulation for speed controls. That is called PWM, pulse width modulation. So basics of PWM is a technique that varies the duty cycle of a signal to control the average power delivered to a motor, enabling smooth speed control. So this is the control the power systems and the motor will running smoothly. The next one is microcontroller implementation. So microcontrollers can generate pulse width modulation signal with precise timing and duty cycles to achieve the desired motor speed. So that is the microcontrollers work. Then energy efficiency. The pulse width modulation control is more energy efficient than resistive speed control methods. So as it minimizes power dissipation in the motor drive circuits. Then high-speed circuits for bi-directional motor controls. That is one of the circuit we are using in the motors and actuators. So reversing motor direction. High-speed circuits allows microcontroller to reverse the polarity of the voltage applied to a motor, enabling bi-directional controls. Then brake and fast functions. Such bridges can also provide braking and posting functions by shorting the motor terminal or disconnecting power respectively. Then robot design. So H bridge circuits are designed to handle high currents and protect against faults, making them suitable for various motor control applications. So this is usually in the robust design. Then efficiency and control. Such bridges allow the efficient, precise, and versatile control of motors, making them a popular choice in many robotic and automation systems. So these are all the HP circuits used in the motor controls. Then stepper motor control using microcontrollers. This is the precise position control, open loop operations, and the torque speed controls application. These are all the stepper motor controlling. So the stepper motors can be precisely controlled by microcontroller to achieve accurate positioning and angular displacement. Then open loop operation, that is stepper motor can be operated in open loop mode where the microcontroller previously times the activation of the motor windings. Then torque and speed control, microcontroller can adjust the drive, current and stepping sequence to control the torque and speed of stepper motors. Applications. Stepper motors are widely used in 3D printers, CNC machines, robotics, and other applications requiring precise position controls. So this is servo motors. This also position control, feedback monitoring, then torque control, speed control. These are all controlled by the microcontrollers. Then sensor integration for closed loop controls. So sensor input and the control algorithm and motor output. These three steps followed by the sensor integration for closed loop controls. Then practical applications. So this is industrial used in the industrial automations, then automotive systems and consumer electronic systems. So these are all the systems used by controlling the motors and actuators by microcontrollers. So in the future, as the technology continues to advance, the integration of motor actuator microcontrollers will become more seamless and widespread. So enabling increasingly sophisticated and intelligent automation solutions across various systems. So these are the microcontrollers, how to control the actuators and motors used in the IoT based industrials and equipments. Thank you.